Hey guys, today we start with function inverses and that idea of an inverse and inverse operations and things like that. So what is an inverse when we start talking about mathematically speaking? Well, what I'd like you to think about an inverse is the kind of an undo. So just like that button that you have, like on Microsoft Word or whatever, it's that undo something. You make a mistake and it undoes it. Well, inverses aren't about mistakes, but it is about undoing that. So think about this whenever you think about an inverse. It's really going to undo something that you did before. Here's what I mean. You guys are all very comfortable with inverse operations. Heck, that's most of the algebra you've ever done has to do with inverse operations. When you solve equations, you're using inverse operations. So what that means is, how do you isolate this value of the variable? And think about when you solve equations, how do you isolate that x? So for example, if I add 3 to that x, how do I isolate it? How do I go backward from that addition? Well, that's not hard, right? To get back to x, we just subtract 3. So those are considered inverse operations, addition, subtraction. Other ways, like if you said, to get x alone here, when it's 3 times x, how do you get back to x? Well, of course, division, right? You divide by 3 and you get back. So again, inverse operations, multiplication and division. When you square something, okay, so in a way, how do you unsquare that to get back to x? Well, of course, we take the square root, right? And that'll get it back to here. And the square root is just a generalization of powers and roots, right? So to undo a power, you take the root. To undo a root, you take a power, okay? Even with a trig, like here, you're applying something, the sine of some angle is opposite over hypotenuse, for example. But what if you want to get back to this? If you want to know the angle? Then we just use the arc sign or the inverse sign. So, and I want to bring this one up because you've seen this before in geometry when you saw a trig. And remember, that's not an exponent. This is just implying that it's an inverse to this. So we'll come back. We will come back to that. Okay, so these are all things you're familiar about. Maybe something you're not, though. This, okay? So how do I undo this? In other words, how do I isolate this? How do I get this alone? Like, what am I going to do to get x? Here, what do I have to do to this base? This is the base of an exponent. Well, what do I have to do to that? Well, this will be something new to this exponent. And that's something we're going to learn in this chapter, logarithms. Okay, so this logarithm will undo this. So you apply the logarithm to this exponent, and that's going to give you back your x. Okay, so that's what this video isn't about, but that's coming up really, really soon. So when we start talking about inverse operations, what does it mean to undo a function? Okay, and so let's just talk about what the inverse does and what it is and how to recognize it. Okay, so first off, a quick review on a function, right? A function is just it's a rule that takes in any input, and you take one input and you're allowed to have one unique output. Okay, so you put in A, get out B, and like all functions, they are graphable, and we've seen in function notation. This is what we would say here. So in this case here, right, we put this in, we're just saying f of A equals B. Okay, so straight up function. Well, we've also done a composite of functions. So what if I took that output and put it in a different function, a completely different function? Well, this output, of course, goes in, it follows some rule, and we get an output, right? And again, just like anything, we can graph that. Okay, so notice what we have here. Now, if I label these two functions here, what we've just shown is a function composition. In other words, we've put it into this function first. We've done some calculation, and it spits out an output, which now goes into this function. And that's what this notation is for. It's saying whatever the output of this function is, now we're putting it into G, and we get a new output. So this is what that would look like according to this, what we have up here, right? F of A plugged into G, we'll get out C, and that's just everything we have here. Okay, well, what happens if instead of getting out that C, we get out an A? So in other words, we put this a into this function, it's, spits out a b. Then we take this b and we put this and it spits out an a. Okay, so basically whatever happened in here, right, it was undone by this. Okay, so it undid that. And notice what happens to the graphable points. This is AB and this is BA. Okay, so that's kind of interesting, and this is the way that would look here. And if you look at this right here is the definition of an inverse. It undid that. So this is the definition of a function inverse. It is a function that undoes another function. So what we say about these, since we've identified what they do, we call these function inverses. They're inverse of each other, so they're in pairs. Just like addition and subtraction kind of comes in a pair. So this is the way we show it. We say that given our little diagram here, we say that g of x, it undoes this. So g of x is the inverse of function f. Okay. But it's also f of x is the inverse of g of x. So it could be the same way both ways. So remember, they work together. They are inverses of each other. Okay. Okay, really briefly, like if I had some function, and then of course now we have its inverse of here, we say inputs and outputs. A really easy way to recognize too is, remember my outputs of my f of x here, if I put them into the inverse, my outputs are going to be the inputs. So tabularly, like just by a table, really simple to see inverses. But of course, it has to be good for absolutely every input. These aren't the only input output, but these are just three elements of input output. So this by itself isn't proof that they're inverses. These are just really good clues though. Okay. Another way that you can tell what a function inverse is if you take some function and you go ahead and plot it continuously. And again, these are just four elements, right, of the domain and four elements of the range. And so, but we went ahead and plotted those and then you put a continuous line on it. Okay, so if I were to take that now, and then notice I just reversed it over here. Okay, and if I were to plot these points and make a smooth curve, I would get something that looked like this. So the way that we can recognize when a function is its inverse or vice versa is it's going to be symmetric across this line. And notice, this line y equals x, because that means these are just interchanging, right? That's what these are doing. Like here, they're just interchanging. 1 into 2 and then 2 into 1. Okay, so that's a handy way to remember this guy right here. Oop, let me back that up. Okay. Now a line that's perpendicular to this line here, with a slope that's perpendicular, any line with a slope that's perpendicular will cross those two graphs at an equidistance apart. So this distance here is going to be the same distance as here, no matter what. And we can see that just by the coordinates. And of course we get to here, what's that? That's our 4, 4, which we can say is on both of these. And we can say that whenever they're the same, it's just an intersection of our two function inverses. And it goes that way all the way along. Every one of those are just inverse points. So in here to sum up for our first little video, just as an introduction to what function inverses are, remember they come in pairs. Okay, you can think of it as the undo functions. You can also think of just the swapping of x and y's as input output. And then of course our graph over here is very characteristic because it's symmetric across this. So if you can graph one function just by symmetry, you can graph its inverse. Okay. All right, so go on to video 2, and this is going to actually show us some functions. We're going to work with them and learn how to calculate them. Okay, so we'll catch you in a bit.